Good morning, students. In last lecture, we understand that every body in the universe attract another body with a force which is called the gravitational force. This is the gravitational force. And what is about the celestial bodies? We know that most of the celestial bodies are revolving around the different celestial bodies, like the planets revolve around the sun. This is the planet, like the earth, it revolves around the sun. What makes this planet revolve around the sun, or we can say the satellites revolve around the planet? So what is this force which act between them to revolve it, to make it revolve around this another object? It means they need some force, and this force is called the gravitational force. This gravitational force which is acting between the sun and the earth, it makes the earth to revolve around this sun. Now this force which is act towards the center is called the centripetal force. Centripetal force. What is the centripetal force? If you want to revolve an object around any point, if you want to revolve, suppose you want to revolve a stone around this point, you have to connect this stone with the thread. That's why you can revolve it. It means you need some force which can revolve this object around the center, and this force which act towards the center, this is called the centripetal force. You can write the define here. A force acts on a body moving in a circular path, and is directed towards the center, around which the body is moving. So what is the centripetal force? If you want to revolve an object around the center, around any other object, it needs some force, and this type of forces which act towards the center, this force is called the centripetal force. And this centripetal force make an object to revolve around another object. And the celestial bodies like the planets and the sun, in this forces from where these objects get this force, centripetal force. They get this force by the gravitational force which is acting between these two objects. Okay, now you can write the importance of gravitational force. Importance of, or we can say the importance of universal law of gravitation. We have a study about the universal law of gravitation and what is the importance of this law. First, we saw that a revolving body like the planet revolve around the sun due to this force, centripetal force, and they get this force by the attraction force acting between these two objects. Okay, तो it means कि कोई ऑब्जेक्ट अगर रिवॉल्व कर रहा है, कोई प्लैनेट्स रिवॉल्व कर रहा है या कोई सैटेलाइट रिवॉल्व कर रही है अराउंड द प्लैनेट, तो वहाँ पे उनके बीच में सेंट्रिपेटल फोर्स कहाँ से मिल रहा है? उन्हें मिल रहा है उनके बीच में लगने वाले ग्रेविटेशन फोर्स से. तो यू कैन राइट द इम्पोर्टेंस ऑफ दिस फोर्स, that is the force, the motion of the planet. You can write the motion of planet around the sun is due to this gravitational force which is acting between this planet and the sun. Second one, the force which bind us on the earth. We know that we are on the earth, and what is this which make us bind towards the earth? Why we are here on the earth? यहाँ से escape करके भी जा सकते हो आप, पर ऐसा नहीं होता है. because you are getting some force of attraction by the earth. This is called the gravitational force. So we can say the force that bind us to the earth. This force bind us to the earth. And what can be the other importance? Its importance can be the motion of the moon. It means if a satellite is moving around the earth, so this type of motion means satellite is able to move around the planet is due to the gravitational force which is acting between the planet and the satellite. So we can write here the motion of the moon around the earth. It is possible due to the gravitational force which is acting between them. And the tides. Do you know about the tides? Tides means sometimes we saw that the sea level goes on increasing and sometimes goes on decreasing on the earth. This water level goes on increasing due to the gravitational force acting by the moon on this sea water, so that water level goes on increasing. आपने देखा होगा कि समुद्र जहाँ पे होता है वहाँ पे एक बार पानी का लेवल ऊपर बहुत ज़्यादा ऊपर चढ़ जाता है और एक बार बहुत ज़्यादा नीचे आ जाता है. तो ये जो ऊपर चढ़ जाता है इसको हाई टाइड बोलते हैं. हाई टाइड क्यों होता है? क्योंकि मून का ग्रेविटेशन एक्ट कर रहा है वाटर के ऊपर. डेट्स वाई इट मूव्स टूवर्ड्स द मून, जिसको आप बोलते हैं हाई टाइड. और ऐसे ही जब ग्रेविटेशन फोर्स मून का नहीं होता है तो लो टाइड हो जाता है. तो इट मीन द टाइड्स ऑन द अर्थ, दिस टाइड्स ऑन द अर्थ इज ड्यू टू द gravitational force of the moon and this sea water. Tides are due to the moon and the sun. Due to this moon or the sun, that high tides and low tides become. So this is the importance of universal law of gravitation. These are the importance. Now we are going to study about free fall. What is a free fall? Free fall means if something is here on this earth and we move it, when we drop something in the influence of this gravitational force which is acting by the earth, this movement, this falling of the object on the earth under the influence of the gravitational force acting by the earth is called the free fall. Suppose example, आप suppose लिफ्ट में हैं और लिफ्ट का रस्सी टूट जाती है, तो अब क्या होगा? अगर रस्सी टूट जाती है तो आप अंडर द ग्रेविटी ऑफ अर्थ की ग्रेविटी की वजह से आप नीचे की तरफ गिरेंगे. तो ये जो नीचे की तरफ गिरना है ड्यू टू द अर्थ ग्रेविटी, इट्स कॉल्ड द फ्री फॉल. Okay. In free fall, what makes the object to changes its velocity? Suppose we drop something from the height. What happens? We find that initially its velocity is 0, but its velocity goes on increasing. It means it has some acceleration. And according to Newton's law, we know that if we want to increase the velocity of an object, suppose the velocity is moving with the initial velocity of 0 and we want to increase its velocity. We want to change its velocity either from rest or from a moving condition. So if we want to change the velocity of an object, we have to apply some force on it. So if an object is dropped from some height, what caused this change in velocity? This is the force. And from where this object gets this force? This force is acted by this earth. So it means earth act a force on the object due to which its velocity goes on increases. So this type of force is exerted by the earth is called the gravitational force. And we know that its velocity is going to increases, so it should have a accelerated motion. I have already explained you that if the velocity of an object is changes, it means it has an accelerated motion. where acceleration is v minus c upon t. That is the rate of change of velocity. What is the rate of changing the velocity? The rate of changing means in how much velocity changes in 1 second. So if a body is free to fall on the earth, so it has some acceleration due to the which is caused by the force of the exerted force by the earth, and this acceleration which is caused by this gravity is called the acceleration due to gravity. This acceleration is caused by this gravitational force, this gravity, so it is called the acceleration due to gravity, and this acceleration due to gravity is represented by small g. Okay, suppose for example, here is this earth and a body is free to fall on this earth having the mass m. Okay, initially it has the velocity of 0. Now it is free to fall on this earth. So according to Newton's second law, I know you don't know about the Newton's second law, but Newton's second law means the force exerted on the body, the force which caused the acceleration on this body, is equal to the product of the mass and the acceleration produced in this body. It means how much force is exerted by the earth on this object. It is equal to the product of the mass and the acceleration which is produced by the gravity on this object. So this was Newton's second law. Actually, we know that the force exerted on an object make an acceleration in the object. So we can say the force is equal to mass multiplied with the acceleration which is produced in the object. Okay, this is the equation first. Now we know that for a moving body which is free to fall on this earth has the acceleration which is called as acceleration due to gravity, and it is represented by small g. So we can write here F is equal to m into g, where m is the mass of the object and g is the acceleration due to gravity which is caused by the gravitational pull of the earth. Okay, now in first part of the video we have studied that F, the force of attraction act between these two objects, is equal to G, universal gravitational constant, m1 into m2 upon r square. What is m here? M is the mass of the object which is falling on the earth, and m2 is mass of the earth on which this object is falling. It means we are going to find the force between the force is what is the force which is acting between this object and this earth. So this is equal to the G, m1 that is equal to the mass of the object, m2 this is equal to the mass of the earth upon the d square. Here d square is means we can say the radius of the earth. In comparison to this radius, the distance is so too small, so we can write it like a we can also write here the radius of the earth. Okay, this is the equation first and this is our equation second. We can compare these equations because both are representing the force exerted on the object. So we can simplify it by equation first and second. The force is equal to m into a, and then force is also equal to the g m1 me upon d square. So we can write according to by equation first and second, we found that ma is equal to g m me upon d square. We can cancel m to m, and here should be g, not the a. Now g is equal to g me upon d square. What is this g? G is called the acceleration due to gravity. It means the acceleration which is produced in the object due to the gravity of this earth is called the acceleration due to gravity. You notice that you will surprised to know that this gravitational force, this acceleration to gravity do not depend on the mass of the object. It only depends on the mass of the earth or the radius of the earth or the universal gravitational constant, which is always constant. So this value of g do not depend on the mass of the object. It means by changing the mass of the object, the acceleration to gravity, the value of this acceleration do not changes. You will surprise to know that if you fall a paper and a stone together with from some height, you generally you find that the paper reaches the earth few seconds later than this stone. This is because this is the paper and this is the stone. This is because this paper has a large surface area, so the resistance of the air, this is here is air, so air exerts some resistance on this paper or also on this stone. Since stone has the high mass, so the resistance exerted by the air on this stone is less as compared to the paper, so that the paper takes few seconds more to reach the earth as compared to this stone. And what will happen if we make vacuum here? Vacuum is there is no air. आप एयर को हटा दो यहाँ से. Now अब आप दोनों चीज़ों को एक साथ डालो तो you will surprise to know that the paper and the stone will reach the earth at the same time, because the acceleration produced on these two objects are equal. It do not depends on the mass of the object. It only depends on the mass of the earth, or the radius of the earth do not depend on the mass of these two objects. So the paper and the stone will reach the earth at the same time. Okay, this is called the acceleration due to gravity, small g. Now acceleration to gravity depends on some other values, like the I am writing here the formula g is equal to g me upon d square, where d is the actually the radius of the earth. We can also write it like g me upon re square, where re is the radius of the earth. So the value of g depends on the radius of the earth. We know that the earth is not spherical, it is sometimes oval in shape. It is like this. This is called the pole and this is called the equator of the earth. Okay, and this is the center. You will find the radius of the pole, and suppose this is the radius of the earth. Radius of the pole is less as compared to the radius of the earth. Since it is some flat, so we can say the radius of the pole is less than the radius of the earth. And what is about this acceleration to gravity on these 2 points, the pole and the earth? Since acceleration to gravity is inversely proportional to the radius of the earth, so by increasing the radius of the earth, the value of g will be decreases. The acceleration to gravity on the pole is higher than the acceleration to gravity on the equator. The acceleration to gravity on the pole is greater than the acceleration to gravity on the earth, because we know that the radius at the pole is less as compared to the radius of the equator. Okay, second thing, first thing is that the value of g is larger at pole and is smaller at equator. Second thing is that the value of acceleration to gravity is maximum at the surface of the earth. It is maximum at this surface. If we move towards the center of the earth, we will find the acceleration to gravity is decreases. By moving towards the center of the earth, the acceleration to gravity decreases, and you will surprised to know that at the center there is a zero acceleration to gravity. Here is no acceleration to gravity. When we move from the surface toward the center, the acceleration to gravity goes on decreasing. Same as if we move in upward direction from the earth's surface earth. If we move in upward direction, the acceleration to gravity is also decreases. So it is maximum at the surface of the earth. It is also decreases when we go towards the center. It is also decreases when we go up to the surface of the earth. Okay, this is all about the acceleration due to gravity. Now the calculation for the value of g. Calculation the value of acceleration to gravity on the surface of the earth. What is the value of this small g? Surface of the earth. We know the formula small g is equal to g me upon re square. Here we know the value of g. It is universal constant, gravitational universal constant, which is always constant in पूरे यूनिवर्स में कांस्टेंट वैल्यू होती है इसकी, तब इसको बोलते हैं यूनिवर्सल ग्रेविटेशनल कांस्टेंट. 6.67 10⁻⁻11 न्यूटन मीटर स्क्वायर पर kg स्क्वायर. Okay, multiply with the mass of the earth. The mass of the earth is also a constant value. It is equal to the 6 into 10⁻24 approx kg upon the radius of the earth. It is approx 6.4 into 10⁻6 meter square. And by solving this value, I have already told you that you should write these numerical values together and the value of this powers together. You can solve it easily. After calculation, we will find the value of g is 9.8 meter per second square. Okay, this is the value of small g on the surface of the earth. What happens now if some object is free to move? Yeah, it is falls on the earth under the influence of the gravitational force of the earth. We have already studied the three equation of motion, that is v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. Okay, we know that v is the final velocity, u is the initial velocity. In first chapter we have already studied about these equation of motion. A is the acceleration, t is the time, s is the distance, and these all values we know already. So for a body which is falls on the earth under the influence of this gravity, we can say the distance covered by the body can be represented by the small h. डिस्टेंस है, अब ऊपर से कोई चीज़ नीचे आएगी तो आप उसको हाइट दिखा सकते हैं, कैन बी रिप्रेजेंटेड बाय h. और इफ योर बॉडी इज मूविंग, इस बॉडी इज फ्री टू फॉल ऑन दिस अर्थ, it means the acceleration produced in this body is due to the gravity of the earth. So we can replace the a by g. So what will be these three equation of motion? It will be v is equal to u plus gt. What is g here? G is the acceleration to gravity. H is equal to ut plus half gt square. Okay, when a body is free to fall under the influence of this gravity, then we can use these three equation motion in this modified form, that is h is equal to ut plus half gt square. We can write v square is equal to u square plus 2gh. Okay, is it clear? These are the three equation motion in modified form when some object is falls on the earth under the influence of the gravity. Okay, now what about the gravity? Can we say this acceleration to gravity can be positive or negative? What is about this sign of g? We know that retardation, na? So if we drop an object from some height, we know that its velocity goes on increasing. Since velocity goes on increasing, so its acceleration will be positive. We know that acceleration will be positive since the velocity goes on increasing. Now what will happen if we throw something in upward direction? We know that its velocity goes on decreasing with the decreasing velocity. If the velocity of the object is decreases, we know that its acceleration is negative. It means g should be negative. You should understand it, that if we throw something in upward direction, the g should be negative with should have a negative sign, and if we drop something from certain height, g should be with a positive sign. So we can write this formula in other modified form. If we throw something in upward direction, we can write here like v is equal to u minus gt. Since g, acceleration to gravity, has a negative sign here, and h is equal to ut minus half gt square, and v square is equal to u square minus 2gh. These are the three equation of motion for a body which we throw in upward direction with certain velocity. Now we are going to do some numericals based on these equation of motion. Like first example is this one, this numerical. You can write the numerical. A ball is thrown vertically upward with a velocity of 49 meter per second. Something you throw suppose you are throwing something in upward direction. If you want to throw something in upward direction, you have to give some velocity to this object. Initially the object is moving with this velocity, so we can say that this is the initial velocity of the body. We represent it by the small u. Calculate the first part, the maximum height to which object will rises, and second part you have to find the total time taken by object, total time taken by this object, this ball, to come to the surface of the earth. First we should write the values which we are getting from this question, that is we are throwing something in upward direction with this velocity. It means this is the u is 49 meter per second. We know that if we throw something in upward direction, after attaining its maximum height, its velocity, its final velocity becomes 0. Okay, so we can write here the v is equal to 0. If we throw something in upward direction, at maximum height its final velocity becomes 0, so we can say v is equal to 0. And since it is moving in the under the influence of the gravity, so we can say the acceleration produced on this body is due to the acceleration to gravity, which is equal to minus 9.8 meter per second square. Why I am writing here minus sign? Because we know that we are throwing something in upward direction, so acceleration will be negative since its velocity goes on decreasing. Okay, first you have to find the maximum height to which it rises. It means you have to find the h. Which equation of motion can use in this question? We can use the third equation of motion, that is v square is equal to u square minus or plus 2gh, and you can put the value v square is equal to u square minus 2 into g माइनस प्लस माइनस हो गया, प्लस था माइनस का ये था तो प्लस माइनस माइनस लिख दिया, एंड मल्टीप्लाई विद द एच. बाय कैलकुलेटिंग दिस वैल्यू 2 into 9.8 into h is equal to 49 into 49. By calculating it, we can find the value of h here. 49 multiplied with the 49 divided by 2 into 9.8, 0.0, 49 2 2 is a 4. Its value will be लगभग कुछ ऐसा होगा 122.5 meter. So this is the maximum height attained by this ball to attain the maximum height. This is the time taken by the ball. Sorry, this is the maximum height which is attained by this ball. Now second part is total time taken by the ball to come on the surface of the earth. We can find the time taken by this ball to cover this height by using you can use first equation of motion, v is equal to u plus gt. You can write the value of v. What is the value of v? V is equal to 0 is equal to u minus 9.8 multiply with the t. 9.8 into t is equal to 49. 9.8 अपॉन में लेके आते हैं और कैंसिल करते हैं. 9.8 0 10 2. It is 5 seconds. 5 seconds. The ball take 5 seconds to reach its maximum height, and the total time taken by the ball to reach to the ground. 5 seconds to move in upward direction and 5 seconds it will take to come to the ground. So the total time taken by the ball, it is 10 seconds. This is the time which is taken by the ball to come back to the ground. Now the one more question. This is also a question of NCERT book. A stone is thrown vertically. A stone is thrown vertically upward direction, and initial velocity of 40 meter per second. Now what is this? This is the small u. In question here, g is equal to 10 meter per second square. You have to find the maximum height attained by the body and the net displacement, total distance covered by the body. Okay, you have to find the total distance. You have to find the total maximum height attained by the stone, and also you have to find the displacement and the distance covered by the body by this stone. So you know that u is equal to 0, g is equal to 10, and u is not 0, u is 40 here, and v is equal to 0 because at maximum height its velocity will be 0. I have already explained you in last question. So you can find the value of h, like in last question we find the value of h. V square is equal to u square plus 2gh. So put the value is equal to 40 square minus 2 into 10 into h. By solving this equation, we will find its value will be 80 meter. Now what will be the total displacement of the stone? Since stone start from here and after attain to its maximum height, it again come back to this point only. It means the displacement of this stone is 0. So you can write the displacement of the body is or stone is 0. And what is about the distance cover? Distance cover is 80 plus 80, that is 160 meter. Few more questions we will discuss in next video, and about the mass and the weight. Okay, not so well. Okay, bye.